Hi everyone, Mrs. Below here. In this video I'm going to be going over scientific notation. So scientific notation is something we're going to use a lot in this class, and it's really important to be able to recognize it, read it, and be able to write in it. Now the purpose of this notation is for really big or small numbers. Okay, so if you have, especially in chemistry, we're talking about really big numbers. We're talking about like so many different types of like atoms or molecules. Those are so tiny that when we're counting them, we're going to be counting lots of them. So it's easier to write in this notation to represent that instead of writing out a number with a bunch of zeros. Or if we're talking about something really, really small in size, again, it's easier to, like if we're weighing something maybe really small, it's easier to use scientific notation, again, instead of writing out a bunch of decimals. So this is the format we're going to be using. So this is the number right here without all the zeros, okay? So it's like the simplified version of the number, representing that with m. So m is a number greater than 1 but less than 10. So it's a number between 1 and 10 basically, and usually we're going to have usually like 2 to 3 decimal places. So in this case we're about like 3 to 4 significant figures. This one has 4. Usually we're going to have 3. And then you're going to have times 10. Okay, so there's your times 10 with some type of exponent with it. And this exponent is representing all those zeros basically. Okay. If it is a positive number like this one, that's talking about a really big number. And again, this is going to be n is a whole number, okay? And it can be positive or negative, okay? This case, this number is positive because this is a really big number. If it had a negative in the front, then it would be a very small number that has a lot of decimal places. So again, kind of what I just said. So when we're converting back and forth between these, it's important to, again, think about that. So if we have so converting into scientific notation. So if we want to take a regular number that has a lot of zeros, maybe something like these numbers, and get them into scientific notation, we're going to have to move the decimal so that we're going to have to move the decimal until there's 1 digit to the left. So you want to have something in the ones place. Okay, so like this is the ones place, this is the ones place. You want to have just one number there. Okay, and how many times you move the decimal to get to this point so that you have one number in the ones place, that's going to be your exponent. So for large numbers, you are going to again have a positive exponent, moving the decimal to the left. So again, the 65,000, here's where the decimal normally is. And to get it into scientific notation, I would move it to the left 1, 2, 3, 4 times. That's why this number is a positive 4. Now again, don't get hung up on memorizing this stuff right here. I'm actually don't get too much hung up on that, left or right, because we're gonna be going back and forth between regular notation, so it's a standard notation, and scientific notation, but we're also going to be going in the opposite direction later, so don't get hung up on memorizing that. Versus for small numbers, again, the exponent is going to be negative. So for this number, 0.0078, I had to move it 1, 2, 3 places to the right here. So again, it looks like this. And that was 3 places. That would be a negative number. So again, don't get too much hung up on like left or right. Just really focus on this part. Large numbers have a positive exponent. Small numbers are going to have a negative exponent. All right, so I'm going to do the first 2 examples, and then after that I want you to pause the video and I want you to try these 2 on your own and then check your work. All right, so again, this is a really big number. Instead of writing out all those zeros, let's write this in scientific notation. So for these examples, we're going from standard notation to scientific notation. But just be aware that we can go in the opposite direction. I'm seeing, I'll do some examples of those as well. All right, so I'm going to start with my decimal here, okay? And again, I'm going to move it until I just have one number, so like in the ones place. So I just have one number to the left of the decimal. So I have to move 1, 2, 3, 4, 5, 6, 7, 8. I had to move 9 places to the left. So the decimal is going to be there. I'm going to write this as 2.3, right? There's only one number here. And I had to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. So times 10, this part is always the same. Times 10 to the 9th. Now I moved the decimal 9 times, and it's a positive 9 because this was a really big number. Now let's go ahead and do an example with a really small number. So again, I want to move the decimal until I have just one number to the left of the decimal. So I'm going to move 1, 2, 3 places. There's my decimal. So 3.3. Again, there's only one number to the left of the decimal in the ones place. Times 10, that part's always the same. And I moved it 1, 2, 3 times. But since this is a decimal, a very small number, it's to the -3rd. So go ahead and pause this video and try the next 2 problems on your own. All right, now let's go ahead and check your work for those 2 problems. So for number 3 here, again, here's my decimal. Again, I'm going to move until I have one number to the left of the decimal. So 1, 2, 3, 4, 5. So I have 7.23. Again, this part's the same, times 10. And I move the decimal 5 times. So it's going to be to the 5th. And it's positive because this is a big number. For number 4 here, here's my decimal. Again, I'm going to move it until I have one number to the left of the decimal. So 1, 2. So 5.1. And again, this part's times 10. That part is always the same. And I only moved it twice. So 2, and then we make that negative because this is a small number. It is a decimal. I do want to add a couple more example problems here. Okay. So let's say you have something that's already in scientific notation. I'm just going to make up a number to the, let's do 4th. Okay. And let's say you want to get this into like a regular number. Okay. So basically all you would do is you would take this number that we have here, I'm just going to move this over, and you're just going to move the decimal. We're going to move it to the right 4 times because this 4 is indicating that this is a really big number. So I want it to be a big number. So to get more zeros on this, I'm going to move it to the right 4 times. 1, 2, 3, 4. So there's the decimal, and then I'm going to add these zeros. So this number, okay, so this number in scientific notation is this number in standard notation. So that's for a big number. We would move the decimal to the right because it's a big number, and I moved it to the right 4 times. So now let's do one with a really small value. Oh wait, hold on. We'll do 1.6 times 10 to the negative, let's say 5th. So this time I would move the decimal. Let me just move this over to give myself some more room. I'm going to move the decimal this time. We're going to move it 5 times, but I'm going to move it this way to make this number small because it's to the negative 5th. So I would move it 1, 2, 3, 4, 5. So my decimal is there, and then we put in zeros as the placeholders. So 0.1, 1, 2, 3, 4, 5. So I have 4 zeros. 1, 2, 3, 4, 1, 6. So this number, that's it in scientific notation. This is the number in standard notation. You can also use your calculator to help put these you have to be able to put these numbers into your calculator in scientific notation as well, because you don't want to be typing out a bunch of zeros all the time when punching things into your calculator. All right, so I'm going to go ahead and go over how to put this into your calculator. This is really important because you're going to be doing this a lot throughout the semester. All right, so let's say I have 0.1 times, so let's say we're doing some, I don't know, math in class, 0.05. Okay, I have to change, whoopsie. This is to the negative. Here, let's just go ahead and change this to be 0.01. 0.01 times 0.005. Okay, there we go. Small change in the notes there. All right, so I punched this into my calculator, and I'm getting this right here, 5e negative 5. That e in your calculator is standing for that times 10. It stands for scientific notation. So therefore, 5e negative 5 in the calculator, that's the same thing as writing it out in scientific notation like this, or in standard notation like this. So I'm going to go ahead and go over these steps right here for how to put numbers into your calculator like that. So I'm going to actually punch in 5e negative 5. I'm going to show you how to do that. All right, so we're gonna do 5. We're gonna do 5e negative 5, because instead of typing maybe typing this number over and over again in a decimal, we could punch it in scientific notation. So I'm gonna go 5. We're gonna hit this blue button right here. So this second button, it's on most calculators, it's blue. And so if you look on your calculator, that number corresponds to what I'm seeing on the calculator that's in blue. And then you're going to hit the button that's right above the 7. It looks like a comma, and you can actually see those 2 blue E's to get this E right here. And then you do the exponent after that. So this was 5e negative 5, which is the same as saying 5 times 10 to the negative 5th. Now make sure that you hit the negative and not the minus button. The negative button's right down here under the 3, and then 5. So if I enter it, it'll look like this. Your calculator starts to default to this method once you start to get into really small numbers. So go ahead in your calculator and try this right here to see if you get the same value.